This video clip is part of the EPFL introductory course on information, computing and communication. It is the second in a set of 3 video clips introducing the course. After the first video clip of this introductory lesson, which underlined the exponential developments of the past, this video clip will explain that information and computing technologies have penetrated all sectors of human activity, are particularly important to the tertiary service economies of our post-industrial societies, and have become as essential as literacy and accounting in any profession, from agriculture to industry, commerce, utilities, finance, government, etc. The video clip will conclude by sketching a couple of the most recent emerging trends in information and computing technologies. The 3 pillars of this course, information, communication, and computing technologies, are at the core of all sectors of human activity and professions. Well beyond the sectors and professions that are notably technical, there is not a single non-technical sector or profession that can function today without these 3 pillars. They are clearly vital to all scientific and engineering fields, but they're equally instrumental to softer fields such as agriculture, commerce, social, political, and economic sciences. As suggested on this slide, information, computing, and communication technologies have invaded and become essential to all trades, from the more material ones such as agriculture, industry, and commerce, to the less material ones such as utilities, professional, and administrative services. Many of these sectors depend on these technologies since a long time, at least for data management applications, such as what is called in the trade supply chain management, SCM, enterprise resource planning, ERP, customer relationship management, CRM, professional knowledge management system, KMS, publication and content management systems, CMS, and increasingly education through massive open online courses known as MOOCs. Most of these sectors depend on information communication and computing technologies for automation and process control, especially telecommunication services, of course. Finally, all sectors depend on these technologies to model, simulate, and optimize their operations by monitoring and exploiting so-called big data, i.e. the huge volumes of information that are posted online every day. Today, information is the DNA of our civilizations, while our own real DNA itself is nothing but the detailed information for sustaining life on Earth. ICC technologies are particularly vital to tertiary service economies. Indeed, as suggested by this table, for each of the 10 largest countries harboring 60% of the global workforce, the portions of the workforce involved in the primary agriculture and secondary industry sectors are decreasing everywhere where they are not already small to marginal, whereas the portion of the workforce engaged in the tertiary services sector is comparatively growing, if not already substantial. This is in part due to the fact that the productivity of these primary and secondary sectors have grown in such proportions that ever fewer people are sufficient to produce enough or even more goods for everybody, thanks to mechanization and robotics. Over time, more and more workers find themselves engaged in often less painful and better paid tertiary sector jobs, where the power of mechanization and the automation of robotics are marginally helpful. Instead, the fuel for that sector is information, and its engines are computing and communication. Not only are these vital for the sector, but more of them is the only way to raise its productivity, as mechanization and robotics did for the agriculture and industry sectors. Today, ICC science and technologies underlie most other disciplines. Alan Turing's universal machine has brought to the world the notions of what is decidable and what is computable. Algorithmic work has brought to the world new ways of attacking problems by subdividing them from the top down or from the bottom up. Claude Shannon's information theory has brought to the world the notions of quantifying information by its entropy. Computer programming and grammar work has provided the world with tools for tackling notions of syntax and semantics well beyond computer languages. And work straddling computer architecture and brain sciences has opened broad avenues under the realm of cognitive sciences. Having started as a science and a technology among many others, the field of ICC imposes itself today as a universal tool at the same level as reading, writing, and arithmetic. A tongue-in-cheek American saying states that any good education rests on those three pillars, all starting with R, as a tongue-in-cheek, of course: reading, writing, and arithmetic. Today, a well-rounded education calls for a fourth pillar, of which R is not the initial by any stretch of the mind, but which is nonetheless essential: ICC. Because they have become as important to modern times as Latin or Gutenberg's printing press in their own times, because they are the fuel and engine of the 21st century that already have and will continue to have a deep social, economic, and cultural impact, because they brought mankind new thought processes and tools comparable to those of philosophy and mathematics, and because information is the foundation of life itself, has the ability to create negative entropy out of chaos. It is hard to predict the future of a technology that has been evolving so fast. A couple of important and closely linked trends are, however, emerging today. The first one is that computer-controlled systems are invading every aspect of life in the form of so-called embedded systems, giving the objects embedding them an ability to perceive their environment, draw intelligent conclusions about it, and react consequently, thereby affecting that environment or adjusting their own behavior in a completely automated, sometimes transparent way, so that one talks about such pervasive or ambient computing that it has become invisible. Witness of this trend are the myriad of devices of which the primary function has nothing to do with computing, and which are not the least bit perceived as computers, but are in effect stuffed with so many computerized microcontrollers that one cannot even count them, because their presence has become so natural as to be taken for an absence. Household devices, meters and sensors of all kinds, multimedia devices, smartphones, cameras, vehicles, whether rolling, floating, or flying, fitness gadgets, medical devices, and on and on and on. The second trend, derived from the first one, as the physical and digital worlds are coming together through a tight coupling, equipping myriads of physical objects and their environment with sensors, embedded intelligence, and an ability to react and influence their behavior or their environment through actuators, builds equally many links between the physical and digital worlds. As a result, the physical world is increasingly perceived and mapped out in the digital world, where it influences digital decisions that are in turn reflected onto physical objects and their environment. The physical world is thus increasingly recorded by the digital world, which then influences it in return, to the point that both are so intimately intertwined that one can sometimes legitimately ask which one controls the other. In fact, in his provocative book on superintelligence, Nick Bostrom raises the no longer so science fiction question of not just if, but when a world of robots might take over control from humans and rule the world, including ourselves. This might sound like food for thought for most of us, but it sounds like pretty much a done deal according to Bostrom's logic. ICC technologies are moving so fast that it is hard to predict every turn of their future path, as Niels Bohr quipped with humor in 1957, and this long list of otherwise famous industry leaders failed to see in their time since then. Indeed, the internet did not collapse in 1996. Today's simplest smartphone enjoys a memory 10,000 times larger than 640K. A large fraction of mankind owns several personal computers at home, not to mention tablets and other computerized devices. Their weight has become ridiculous. Their market size phenomenal, even for supercomputers and cloud data centers. And the development of the ICC technologies may be about where the automobile technology was a century ago.